Hi, 5th grade. It's Mrs. Gilka with your flipped math lesson for today, 3-4. Today's objective is I can use exponents to record repeated multiplication of the same number. So we are going to be using these funny little things called exponents, you'll see what those are in a minute, to do repeated multiplication of that same number. I'll show you what I mean in a problem. So here's our first problem. A box of cubes has 5 layers. So you can see there's layer 1, layer 2, 3, 4, and 5. And each layer has 5 rows, so 1, 2, 3, 4, 5, and 5 cubes are in each row. So that means that there are 5 times 5 times 5 cubes in each box. So we are doing repeated multiplication of the number 5. So I've got 5 times 5 times 5, and I'm going to figure out what that equals, but I'm also going to figure out how to use an exponent to show that same problem in a different way. I could do 5 times 5 times 5, so I'm multiplying the number 5 3 times, and with an exponent it looks like this. I use the number 5, which is my base number, and then I put how many times I'm multiplying it together. I'm going to multiply it together 3 times. So I put this little number 3 up here above the 5. That's an exponent. And what that means is 5 times 5 times 5. So if I just saw 5 with the exponent of 3, I would say that means I'm going to multiply 5 times 5 times 5. Now to read this number right here, we don't say 5 with the exponent of 3. We say it a little differently. We say 5 to the 3rd power, and that's how we read it. Now to solve it is a little different. So first I'm going to multiply 5 times 5, and 5 times 5 is 25. Then I'm going to multiply this 25 times the other 5. Okay, so now I'm multiplying 25 times 5, and that's 125. Remember, think of quarters every time you see 25. So if you had 5 quarters, you'd have $1.25. So 125 is the answer to this problem. It equals 5 to the 3rd power. That equals 125. Okay, so let's look at it one more time. 5 times 5 times 5 are the factors that we're multiplying together. The number 5 is the base number. It's what's being multiplied. The 3 is the exponent. It shows how many times we're multiplying that number together. We can write it lots of different ways. Let's try it with 2. 2 times 2 times 2. The base number is 2. The exponent is how many times we are multiplying that number together. We're multiplying it 3 times. So that number is 2 to the 3rd power. To solve it, we're going to multiply 2 times 2, and that equals 4. Then we multiply this 4 times 2, and that equals 8. So 8 is what 2 to the 3rd power equals. Okay, it does not mean 2 times 3. It means 2 times 2 times 2. Well, just like when we learned numbers and we learned how to write standard form and expanded form and written form, exponents, numbers like this, have that as well. Okay, so our exponential notation, it's a special word, is written like this. Okay, so 2 to the 3rd, or 5 to the 4th power, or 7 to the 11th power. These are all exponential notations. Okay, try writing 4 to the 2nd power. Did you write it like this? Good. Try writing 7 to the 5th power. You should have written it like that. Okay, so that's exponential notation. And remember, that means this one means 2 to the 3rd power means 2 times 2 times 2. 5 to the 4th power means I'm doing 5 times 5 times 5 times 5. Expanded form is what we would say this 5 times 5 times 5 is. Okay, so if we had 2 to the 3rd power, the expanded form of that would be 2 times 2 times 2. If we had 4 to the 2nd power, it would be 4 times 4. Try doing 8 to the third power. What would that be? You should write 8 times 8 times 8. How about 10 to the first power? What would that be? It would just be 10. Kind of tricked you there. Okay, let's try another one. This is standard form. So standard form always is just the number. Just the number, that's it. So when we had 5 to the third power, we knew that that equaled 125. 125 is the standard form. So if I said, what's the standard form of 4 to the second power, you would know that means 4 times 4, which is the expanded form, and then you would figure out, oh, that's 16. 16 is the standard form of that number. Okay, so we have exponential form, expanded form, and standard form. And you'll be expected to know what all three of those are, how to write them, and how to solve them. Okay, we have some special numbers, squared numbers and cubed numbers. So I wanted you to know those important vocabulary words. A squared number is an exponent of 2. So if we had 5 to the second power, that number is squared. So sometimes we read it like 5 squared. Or if we had 3 squared, we'd write it like that. Or 9 squared. That just means that number to the second power. It's kind of the same with the word cubed. It's very similar. If we had 5 cubed, it means 5 to the third power. If we did 7 cubed, it would be 7 to the third power. Write 11 cubed. You should write 11 to the third power. What that means is 11 times 11 times 11. Okay? So let's try some. Let's write 4 times 4 times 4 in exponential notation. You should have written the number 4, which is the base number, and the exponent 3, because we multiplied it 3 times. So if you wrote 4 cubed, or 4 to the third power, you got it right. Write 10 to the fourth in expanded form. You should have written 10 times 10 times 10 times 10. Remember, 10 is the base number. The number 4 is how many times we are multiplying that number together. And remember, this does not mean 10 times 4. That's not what that means at all. It means 10 times 10 times 10 times 10. Write 2 to the fifth power in standard form. Okay, to get to standard form, first I have to write it in expanded form. So 2 to the fifth power equals 2 times 2 times 2 times 2 times 2. Then I multiply these first two together. 2 times 2 is 4. Now I take 4 times 2. 4 times 2 is 8. Then I take 8 times 2. 8 times 2 is 16, and then I take 16 times 2, and 16 times 2 is 32. So 32 is the standard form of the exponent 2 to the fifth power. All right, your turn. You're going to write in exponential notation first. So that means like 3 to the second power, 5 to the fourth power, 7 to the 11th power. That's exponential notation. Write these numbers in exponential notation. Number 1. Okay, you should have written the base number 10, and there's 1, 2, 3, 4, 5 of them. So 10 to the fifth power. Number 2. The base number is the number 9, and it is written 3 times, so you should have written 9 cubed, or 9 to the third power. Number 3. 81 is the base number. You should have written 81 squared, or 81 to the second power. Number 4. 7 is the base number. You should have written 7 to the third power, or 7 cubed. Okay, this time you're going to write in expanded form. So write 10 to the 9th power in expanded form. Okay, you should have written that base number 10 and multiplied it 9 times. And that is 10 to the 9th power. Number 6, 35 squared. Write that in expanded form. You should have written 35 times 35. 35 is the base number. Squared would be that number 2 is our exponent. Number 7, 7 to the 6th power. Write that in expanded form. Okay, you should have written the base number 7 and written it 6 times, and that's 7 to the 6th power. Number 8, write 4 cubed. You should have written the number 4 3 times. Cubed means that it is 4 to the 3rd power. So this is our expanded form. Okay, now you're going to write it in standard form, which means you're going to find the one number. You may be given the exponential notation, or you might be given the expanded form, but either way, you're going to need to find the standard form of the number. 10 to the 3rd power. So 10 to the 3rd power means 10 times 10 times 10. 10 times 10 is 100, and 100 times 10 is 1,000. So 1,000 is our answer. Number 10, write the standard form of 12 squared. Twelve squared means 12 times 12, and that equals 144. Number 11, 2 to the 6th power. Okay, so I wrote down 2 times 2 times 2 times 2 times 2 times 2, and 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, and 32 times 2 is 64. So 64 is the standard form of 2 to the 6th power. Number 12, 10 to the 5th power. Okay, so I multiplied 10 times 10 times 10 times 10 times 10, and 10 times 10 is 100, 100 times 10 is 1,000, 1,000 times 10 is 10,000, and 10,000 times 10 is 100,000. And I want to show you something neat about tens. When you do tens in exponential notation, whatever the exponent is, that's how many zeros there are. So if I have 10 to the 5th power, that means there's going to be 5 zeros. 1, 2, 3, 4, 5, and then I put the number 1 in front of it. So you can see my answer down here is 100,000. It has 1, 2, 3, 4, 5 zeros. So that's kind of cool with tens. You can't do that with other numbers, but you can do that with the number 10 when you write it in expanded form or exponential notation form. All right, you are finished for today. Bye.